Hello, in this video, I will explain to you on how to find the node field voltage VA here using mesh analysis. So our goal is to find out VA using mesh analysis. And I will explain to you step by step. And our first step here is to label all the loops. Label all the loops in the circuit. And also we need to find some necessary information to get things done, right? So here I always assume the loop current is going clockwise like this. Okay, so we will have this as loop current I1 and this as loop current I2. Okay, and then here is our ground, so we will have the voltage here is 0 because this is the reference node and this is node A here. So our target is to find out VA, which is the node voltage at this node here. So let's change this into VA because I'm more comfortable with this. And so our goal is to find out VA. But VA here is the voltage across this R3 resistor, right? Because VA is relative to the ground, so we will have this here and this here. But then we can calculate VA using this loop current here. Then what is VA? Okay, because the current should flow from the positive side to the negative side, the one that is positive is I1, right? Because it flows from the positive to negative. So I will have I1 here, but then here I2 flowing to the opposite direction. So I'll have minus I2 here, but we multiply it by the resistance. So that will be multiplied by 8, right? Because the current multiplied by the resistance is the voltage. Or I can rewrite the 8 in the front. So I will have VA is equal to 8I1 minus I2. So this will be tidied up like this. Good. And I think we have labeled all the loops and also extract some necessary information. Okay. And then the second step that we need to do is do KVL for all unknown loops. Right, unknown loops. Okay, here we have I1 and I2, both are unknown. So we need to do KVL at both I1 and also I2. Let's do exactly that. The first KVL that we need to do is on I1. So let's do KVL at I1. What does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. Good. Let's see here, the loop is flowing clockwise like this, and it enters from the negative terminal of the battery. So I will have minus sign, minus 4. We already have the voltage here. Okay, now let's move on to this 4 ohm resistor. So I will have 4, and the only loop current that pass through it is I1. So I will have I1 here. Remember that this is resistor and this is current, so we get the voltage from here, right? And then let's move on to this R3 here. And remember, we are working on I1. So I1 always came first. So we'll have 8 ohm multiplied by the current to get the voltage. So I will have I1. I1 always came first in this equation. And then here I2 is flowing to the opposite direction. If you see here, I1 going down and then I2 going up. So I will have minus I2 from here. Okay, and all of that is equal to 0. Okay, we can simplify things here, right? I1 only came from this and that, so I will have 4 plus 8, that will be 12 I1. Okay, and then I2 only came from this place, so I will have minus 8 I2. Good, minus 4, let's move it to the right hand side, so I will have 4 here. Okay, I think nothing more that we can do from here. Let's save this as equation number 1. Okay, now what can we do next? We need to do KVL at loop I2, right? Let's do exactly that. So we need to do KVL at I2. Again, KVL said that the sum of the voltage in a loop will equal to 0. Good. Now let's start with this 8 ohm resistor. Okay, but to get the voltage, we need to multiply it by the current. Remember, we are now working on I2. So I2 always came first. So I will have 8 I2. But then here I1 flowing to the opposite direction. So we'll have I2 minus I1. Okay, and then let's move on to this 2 ohm resistor. So I will have plus 2. And the only loop current that pass through it is I2. So I will have I2 here. And then we will have this 6-volt battery. And remember, the current enters from the positive terminal. So I have plus sign there. So I have plus 6 here. And all of that will equal to 0. Good. Now I1 only came from this place. I will have minus 8 I1. And then I2 came from 2 places, this and that. 8 plus 2, that will be 10, right? So I'll have 10 I2. And then let's put this 6 to the right hand side. So I'll have minus 6. And let's have this as equation number 2. Okay, now we have 2 equations with 2 variables, right? Equation number 1 and equation number 2. And we should do the third step, which is to solve the equation. Okay, you can use substitutions and eliminations, Cramer's method, or another techniques in linear algebra, but I think the fastest way to do it is by using calculator. Why? Because in the circuit analysis classes, usually you can use your calculator, right? So why not use it to calculate? So let's calculate the equation using our calculator. Let's set this up here as equation solver, which is number 5, and 2 variables is number 1. Okay, now we have this matrix here. All we need to do is to plug in the coefficient. So I will have 12, and then minus 8, and then 4. Okay, we get all the coefficient, 12, minus 8, and 4. And then for the second equation, I will have minus 8, and then 10, and then minus 6. And so we can solve it for I1 and I2. I1 will be our x value, right? Which is minus 1 over 7. So I1 here is equal to minus 1 over 7. And the unit will be ampere. Then what is I2? I2 is this value here. I will have minus 5 over 7. Minus 5 over 7 ampere. But then the question does not ask about I1 and I2, but that is VA. But remember, we get our VA here. We can plug that in, right? So our VA will be 8 multiplied by I1. I will have minus 1 over 7. And then minus 7 over 7. So I will have plus 5 over 7. Okay, so we will have VA here is equal to 8 multiplied by 4 over 7. And that will be 32 over 7. And we can calculate that using calculator, right? So we'll have 32 over 7. What is it? 32 over 7. And I need to get that in decimal. We'll have 4.571. 4.571. And the unit will be in volt. So that is our goal. Our PA here is equal to 4.571. And the unit will be in volt. And that is how to solve this problem using mesh analysis. Okay, hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.